Hello and welcome to this second session on the short video series class 11. Today's program will be balancing techniques. We shall be playing with the intricacies of balancing a redox reaction equation. Now, for example, in the last video we had learned how to find the oxidation number, and even for those molecules and ions where there are more than one atom of a particular element, and we have to find by looking to the covalent structure. Now today we shall be trying to balance redox reaction equations by many methods. I will tell you the tricks when to follow which method. In the description box you will find everything in details, and I'm sure this video will be going to be 30 minutes and you will definitely be interested to rewatch this for a better understanding. Now this is a redox reaction where phosphorus is in the 0 state, oxidation number here it is +5, and nitrogen here is +5, it is +4. Now the one which is oxidized, as you know, is called the reducing agent. The one which is reduced is called the oxidizing agent. And this method of balancing equation is called the ON method, where the change in oxidation number for the entire reducing agent is to be multiplied as coefficient with the oxidizing agent, and vice versa. Now for one phosphorus atom the change is 5, and there are 4 phosphorus atoms, the total change is 20. So you multiply here by 20. And in the oxidizing agent, +1 to +4 the change is 1, and there is only one nitrogen atom in the agent, so the total change is 1. 1 is never written, so this is the starting point. Then you inspect. Hit and trial will make your process complete. Now since there are P4, you multiply here by 4. There is 20 nitrogen, you have to multiply by 20. And you have here 20 hydrogen, and here 4 3s are 12 hydrogen. So we need 8 hydrogen to be supplied by water. So this is 4 water. You will find the oxygen is balanced. Always check. Oxygen is the difficult element present, omnipresent. So you just check whether it is correct or not by counting the number of oxygen atoms. 23s are 60, and you will find 4 4s are 16 plus 46 plus 4, 60. 16 plus 40 is 56 plus 4, 60. Right? So this is the ON method. The bottom line is to equalize the number of electrons lost with the total number of electrons gained. Same thing you will do it here. Phosphorus in calcium phosphate is +5, it is 0. The change is 5, but there are 2 such atoms, so the total change is 10. So 10 to be multiplied with carbon. Carbon goes from 0 to +2 in carbon monoxide. So the change is 2, and there is only one carbon, so the factor is 2 here. After doing this, everything becomes easy. Is 3 2s are 6 calcium, make it 6. 10 carbon, make it 10. 6 silicon, make it 6. And obviously everything is now balanced. You can check yourself, going very fast. It's very simple. If you are handling with a redox reaction, you can first try that, can I balance it by ON method? Now if you are handling an ionic equation, then you have to follow some methods. For example, this is an acidic medium. Oxalate ion, this is oxalate ion with dichromate ion, potassium dichromate in acidic medium, giving you carbon dioxide, chromium 3+ and water, right? Now this is an ionic equation and its procedure is different. Now what I say is, let us take up any one step, say reduction step. Chromium is here +6, don't write the fake charge. This is the real ion having its own charge, and some are neutral. So don't write the fake oxidation number to have a wrong signal that as if it is the real charge. So you can write down below it using a pencil. Now plus 6 and this is plus 3. So this is the reduction step. Dichromate ion is giving chromium 3 plus ion, and then you have to equalize the atom other than the element other than O and H. So there are 2 chromium, you have to multiply by 2 here. Then the next step is to equalize oxygen. There are 7 oxygen excess, so you have to add 7 water. So equalization of oxygen is done by adding water. Then there are 14 hydrogen excess, so that is done by adding hydrogen ion, obviously on the opposite side because it is an acidic medium. Then equalization of charge by adding electron. Electron is -1, so the total charge in right side is plus 6, and here plus 14 minus 2 plus 12. So here we need 6 electron, so that this side will be plus 6, this side will be also plus 6. So this reduction step is over. And let us go to the oxidation step, where oxalate ion has been oxidized to carbon dioxide, and simply by multiplying 2 here, oxygen is also balanced. So we are lucky, no more steps are required, only equalization of charge. So 2 electron, so that oxidation is the loss of electron, reduction is the gain of electron. So that you must make sure that you are not placing electron in the wrong side, otherwise it will be a wrong, erroneous result you will find. Then to cancel oxygen, you have to multiply the whole equation by 3, so that 6 electron get cancelled, and you get the final ionic equation balanced. Dichromate ion plus 14H plus 3 oxalate ion, giving you 2 chromium 3 plus ion plus 6 CO2 plus 7 water. So you can, before submitting, you check element wise, charge wise, the 2 sides are balanced or not. Don't be complacent that you have done correctly. No, you have to test. For testing purpose, you can take oxygen as one of your test element, equalize on both the sides or not, and then charge. Both the sides should have the same charge. It's not the molecular equation, it's the ionic equation. So this is the rules for acidic medium. I have written down. It's nothing very difficult rules. You have to equalize oxygen and hydrogen. In acidic medium, you have to use H plus ion. Now if you are asked to balance in basic medium, where you have, this is the chromate ion, the yellow solution, and this is cuprous oxide is a red solid, and when you heat it in alkaline medium, it's not written, complete equation is not written here. Automatically the balanced equation will carry OH minus and water on some sides. Some cases both may appear on one side, that we will see. Follow the steps, right? Now this is a bluish white precipitate, and this is colorless. So this reaction, we have to follow some little different rules. Now let us take first the reduction step. This is plus 6, this is plus 3. Chromite, it's not chromate, it is chromite, right? So let us do that reduction step. Doesn't matter which step you do first, it is your prerogative, right? Now there are 2 oxygen excess, like the acidic medium, you write 2 water. Then we have 4 hydrogen excess, that you have to do 2 things, because you are adding OH minus ion, which carries both O and H. Therefore again you have to take the help of water. As many hydrogen atoms are excess, same number of water molecules you have to add on the opposite side, and same number of OH minus ion will be on the same side, right? As many hydrogen atoms are excess on a particular side, same number of water molecules on the opposite side, same number of OH minus ion on the same side. You have to do this two things breathlessly in one go, right? So that you can find the hydrogen, 2 2s are 4, 4, 8, and this is 8, and oxygen 4, 2, 2, 2, 2, 4, 4, 8, so this is 4, 4, 8. So everything is balanced, right? Now equalization of charge. -2 here, this is -5 here. So you have to, since reduction, this is 3 electron you have to add, so that this side -5, this side -5. Now oxidation, in the same way you get the solid, because in ionic equation solids, they are not dissociated into ions. If you have not done ionic equations writing, you just look to my slide, the notes, the study materials that I have given in a PDF file in the first lecture. Now that gives you cupric hydroxide, and then copper. First you have to equalize copper, 2. Then how many oxygen atoms are excess? Here 2 2s are 4 and 1. So 3 oxygen atoms are excess on this side, so 3 water. Hydrogen, how many hydrogen atoms are now in excess? 3 2s are 6, 2 2s are 4. So 2 hydrogen. So 2 water here, immediately 2 OH minus here. Then of course water, water on the two sides, water, water on the two sides. So finally you have to bring it to one side, just like you do algebra, you can do that. And then equalization of charge. Here there is no charge, here there is, so here it will be 2 electrons, so that -2, -2. Then you have to multiply the whole equation by 2, so that 6 electron, and whole equation by 3, so that 6 electron get cancelled, and you yourself, after watching this video, add both these sides, and then there will be so many commons. Water and OH minus ion will appear on both the sides. So simplify the equation by bringing water and OH minus to a side which is an excess. That you can do. Now the rules I have given, there will be no problem at all. Now you can also, I don't recommend to do this by this method. Now unless you are very strong at oxidation number concept and balancing equations, it is very, very hard to enter into mole concept. You are IIT aspirant, or you are a NEET aspirant, or a American advanced placement aspirant, so you have to be thorough in these things, right? So this equation can also be balanced by ON method. The change of one to be multiplied with the other. So this is +3 and this is +4. So for one atom, it is change is 1. +3 to +4, there are 2 atoms, so 2 into 1. So 2 is to be multiplied with the OA, and this is +6 to +3. So the change is 3, and there are 2 chromium atoms in the reagent. 3 into 2, 6. 6 is to be multiplied here. So this is 6 2s are 12. So we have to make it 12 here. And this will be 2 2s are 4 chromium. This will be 4 here. And the number of oxygen, 6 4s are 24. 7 2s are 28. 7 2s are 14. It is 38. Now this is 24 minus 38. It is 14. So you have to make it 14 here, so that the oxygen atoms will be equal. Now to make the hydrogen equal, you have to have 28. So you have to have 28 here. And since you find this is not a simplest whole number ratio, then you divide the entire equation by 2. So it will be 3 oxalate ion plus 14H plus 1 dichromate ion to give you 6 CO2 plus 2 Cr3 plus 7 water. You can yourself check. 3 2s are -6 minus 2, that is -8 plus 14 plus 6, and here also plus 6. Charge wise also it is balanced. Now, why I do not recommend this method of balancing the ionic equation by ON method? Because supposing you are not given water or H plus, just written balance by acidic medium, then how to do that? And moreover, there are two charges. One is a real charge. These are the real charges. And the other one is a fake charge. And that might arouse a lot of confusion while you solve that. But when you are strong, then you can apply any method without having any iota of doubt regarding the fake charge in an covalent molecular ion and the real charge of the ion, right? Now, let's take up this redox reaction. Copper nitric acid, giving you copper nitrate NO plus water. Now, this has spectator ions in the right side. Nitrate ion is not at all a important ion or an involved ion in right side. It is a player in the left side. It is giving NO. So, if you go by ON method, 0, 2 plus 2, change is 2 and there is 1 atom. So, multiply 2 here. This is plus 5. This is plus 2. Change is 3 and there is only 1. So, 3 into 1, that is 3. After that, you must make sure, I'm sure you might face a bit of difficulty if you are not focused. If you see that there are 2 nitrogen atoms which are responsible to give NO, forget about this nitrate ion, these are spectators. We can adjust by adding more nitric acid to cater to the number of spectators, right? Now, this 2N will definitely give 2NO because this nitrate ion that we are doing, electron loss and electron gain, is for the product which are produced from the oxidant. This is the product. So, immediately I made it 2 here. Then, since it is 3 copper, I made it 3 copper nitrate, and by doing so, I find that there are 6 nitrate ion going extra in the right side as spectator. But that will be provided by nitric acid. Nitric acid is the provider of the hero nitrate ion and also the zero nitrate ion, which will make the molecular equation balanced. So the extra nitrate ion 6 will be added up to 2, so the final it will be 8. Then 8 hydrogen, so you have to make it 4. Then you will find it is a balanced equation. Now this is what we call the modification of coefficient, where we need to make modification of coefficient for accommodating spectator ion. First we wrote 2, but we modified to 8. 2 plus 6, 8 to accommodate the spectator ion. Now, you could have understood it more clearly if we write down the ionic equation like this. I remove nitrate ion from right side and I do this. And you can try by using the acidic medium method. You will find that there will be 2 nitrate ion required and 2 NO will come. And the remaining, nitrate ion that we are adjusting, it is for this extra nitrate ion that is there in the molecular equation. But that extra, you won't find it ionic equation. You will find by adding the 2 steps, there will be 2 nitrate ion and 2 NO, right? We are going very fast. And I'm sure you will be interested to rewatch. Now, this is very interesting method. EBD, I will be giving you all types of weapons, all type of artilleries. Not to, make a war like Russia is waging a war against Ukraine. It's not that, but the weapons to balance as difficult equation as possible. You have so many weapons and you can apply the one which is economical. Now, this is a disproportionation reaction. You see, the same chlorine is oxidized from 0 to +5 and same chlorine 0 to -1. So in this type of reaction, it's not at all advisable to go for ON method. So another version of ON method is EBD method. EBD means electron balance diagram. So what you do here, you do the same thing, but take only one atom, chlorine 0 here and chlorine Cl -1 here. Nothing, no oxygen, no hydrogen, like ionic equation, but the last step, only one atom and its fake charge, and then by electron balance equalize the charge. So there will be one electron here, -1, -1. Now oxidation, same chlorine has become Cl +5, no chlorate ion, only one atom. Then equalize electron by adding 5 electron. So to cancel electron, you multiply by 5 here. So 5p get cancelled, and that becomes 6Cl0 gives you 5Cl1 minus and 1 chlorine +5. So what we get at the end is called the EBD, electron balance diagram. And looking to this, you can balance this original molecular equation. This is 6 chlorine 0, so we need 3 here, and 5 minus 1 chlorine, so we have to make it 5. 1 chlorine +5, so this already 1 is there. So once we got coefficients from both LHS and RHS, so our problem is much more easy to go for heat and trial. We have 6Cl, and we have 5 + 1, 6 sodium, make it 6 sodium, and then 3 water. That will immediately balance this equation. You try once again. Now, supposing you are given this equation to balance, right? How to do that? This is not an ionic equation. You can't make it ionic. These are all solid gas reaction. No water is involved here. So how to balance this? How will you know that it is not +4? I told you in the last video that iron pyrite or the fool's gold, iron is in the +2 state, and this is disulfide, sulfur is -1. But supposing you do not know how to do it, and there are multiple oxidations, find +2, iron is going to +3, and sulfur -1 is also going to +4. Multiple oxidations and one, of course, reduction. Or here, doesn't matter. Or here or here. 0 to -2. So there can be multiple oxidations or multiple reductions, and there might be one, the other one. At least one of each type should be there. If there will be loss of electron, somebody has to take, right? So to me, I could have done it by the EBD method, making 2 oxidations and adopt the 2 oxidation steps by maintaining the ratio 1:2 ratio. I would have got the final oxidation step and then the reduction step, and then added both the 2, and then looking to the EBD, I can do that. But that is more time consuming than the simple algebraic method I will follow here. So I am telling you another weapon. Sometimes it will be very, very helpful. Not always. So I made the coefficient P, Q, R, S. And you have to assume a particular coefficient as 1. Which one? That is your choice. The more difficult molecule you take as 1, then it will be easier. Less fractions will come. So the more number of atoms are there in ferric oxide. I took R is equal to 1. You could have taken P is equal to 1. But ultimate answer will be same. So I took R is equal to 1. And then I had 3 independent equations. One for iron balance. P, there is 1 iron, so P is equal to 2R. This is equation 1. Already R is 1, so P is already known 2. Now sulfur balance. 2P is equal to S. There is 1 sulfur, S. Don't confuse with this small sulfur, S, that is the coefficient, and capital S is the sulfur atom. So S. So 2P is equal to S. So already P is known 2, so S is known 4. Then the third, oxygen balance. 2Q is equal to 3R plus 2S. So already P and S are known, so we get 2q is equal to 11, so q is equal to 11 by 2. So ultimately we find this 2, 11 by 2, 2, 4, but you can't keep a fraction in a balanced equation. So to eliminate fraction, I have multiplied throughout 2, 4, 11, 4, 8. So how easy it is, if you have done by ion-electron method, that is EBD method, then you would have consumed a lot of time. And I will never recommend to remember these coefficients, there are, in this higher secondary level, you will encounter with innumerable inorganic equations. So you can't remember all the coefficients, right? Now, you tell me, which one you will apply here? You tell me. This is diphosphine, this is phosphine, and it's tetraphosphine. So since it is a disproportionation reaction, right? Minus 2 to minus 1 by 3, it is this is minus 3, minus 3, it is reduction, and this is minus 2 to minus half, it is oxidation. So you draw the EBD is very, very cumbersome, very, very cumbersome, fractional electron. But if you do by A, B, C, there will be only 2 simultaneous equations. There are 2 elements, and I took A is equal to 1. I could have taken C is equal to 1, no problem. So I took let A is equal to 1. So phosphorus balance 2A is equal to B plus 4C, and hydrogen balance 4A is equal to 3B plus 2C. And just like as you do, A is equal to 1, so it is simplified. This is 2 and this is 4, and then you find out simultaneous equation solution. You found that A is C is 1 by 5. A is already 1, C is 1 by 5, and B is 6 by 5. So I wrote down the balanced equation in fractional form, then I eliminated fraction by multiplying with 5, so it becomes 5, 6, 1. So had you done it by hidden trial? No. No, I don't know if you are a genius, mathematical genius, you can. I cannot at least dare solving by hidden trial method to this redox reaction. I have to apply some weapon. Now, I am reminded of this big equation maybe about 10 years before, maybe 15 years before. Some of my students asked me, sir, I cannot balance this. Even my teacher in school could not balance it. Now, do you know what they gave me? They gave me that this water is in right side here, and KCl is in this side, right? So somehow I inspected that the position of water is wrong. Usually water is found in the right side, but the teacher who posed this question to the student might have by chance wrongly written this equation from a source, or maybe some mistake has happened in some source that boy could not do. So he took my help, and I asked him, which method you want? I have trained you with several weapons, but which weapon you apply? Now this is +2 and this is +1, and this is cyanide, it is +2, in cyanate it is +4. So change is 1 here, change is 2 here. So you can multiply 2 to this and 1 to this. So with this you can do nothing. There is ammonia as well as ammonium chloride, which are of different nature. Ammonia is basic, it will go out. Ammonium chloride is acidic in nature, salt. So you can't do anything about it. So my advice to him, go split it into ionic form. So then he converted, he eliminated the unimportant spectators. Chloride ion gone, chloride ion gone. So the only players, this is tetramine copper 2+, cyanide ion, water, this is tricyanide cuprate 2-, and OCN-, ammonia, ammonium ion, this chloride ion, potassium ion, all gone. And then he then he, did it. So this is the first step. This giving you this, of course, with the help of cyanide ion, otherwise how can it give? So 3 cyanide into 3, 4 ammonia into 4, then it needed only 1 electron to equalize the charge. Then cyanide ion has been oxidized to cyanide ion, and he took that step and he applied, the acidic medium rule, because ammonium ion has been formed, so he thought of using acidic medium, so he got 2H plus. Immediately he thought ammonia has taken up some H plus ion to become NH4 plus. Some of the ammonia has been converted to NH4 plus. Then finally, multiply here by 2, so that 2H plus will cancel, and here there is 1 electron, multiply by 2, so that 2 electron get cancelled, and you got this balanced ionic equation. You understand? After getting the balanced ionic equation, it is easy to go for the molecular equation. 2 is the coefficient 2. So this is the molecule. And 7 cyanide ion, 7 KCl plus water. Then 2 potassium cuprocyanide. Right? Then 1 KOCN, 6 ammonia, 2 ammonium chloride, and remaining KCl that is there in this, it was only needing 2K because he counted 7K, and 2 2s are 3 plus 1 4. 2 2s are 4 plus 1 5. So only 2K are needed. So automatically he found that chloride ions are 2 2s are 4, and here also 2 chloride, here also 2 chloride 4. This is all done. So within a minute or two he could balance this equation, but he tried several hours. Even if I said that no, water is to be kept in the left side. So interchange water with KCl, that is the real equation. Otherwise, if somebody gives you a wrong equation with a wrong placement, you may spend years, decades, millenniums. You can't balance it. So you have to judiciously find out the mistake, right? Now, I then asked him to go for, this is a very uneconomical method, the same equation he tried with x, y, z, p, q, r, s, t. So it will be very, very uneconomical method, and he did it. He got the same coefficients that he found by first making it ionic and then balancing it and then getting back to the molecular equation. Now, I have given you some previous year's IIT advanced and main, which you can answer very easily. So I have answered them, but after having discussed all varieties of methods, I am sure I have also answered them, but you don't answer. So you don't look to my answer. You first answer them, check the answer with my solution. Then if you have not understood, then try to rewatch my video, right? So I have given the 2 years, 1990 and 20 and 21, of course, 20. These 2 years, all the IIT problems from this redox reaction and balancing, right? So you will find very interesting, particularly here when it is ferrous oxalate. One of the ferrous oxalate, you find both the ferrous will be oxidized to ferric and oxalate will be oxidized to carbon dioxide. So here 3 electrons are involved. Had it been ferrous sulfate, sulfate is not an oxidant. Sulfate is not a reductant. It will, the sulfur is at the highest oxidation state +6. It will not go beyond +6. So that is a spectator. Only take Fe2+. But if it is ferrous oxalate, you have to both take ferrous and oxalate, so that the number of electrons involved will be different. So you have to find out. So there are so many interesting problems which you can understand. So I think I closed this session. I told you to go for a 30-minute session. I think I have exceeded. So how did you like it? And this next session will be going for the mole concept. Very, very interesting aspects of mole concept. If you have not like it, subscribe it, share it. Bye. Bye.